Hello, I'm the microbiotic Mr. Daycock, and today I'm going to be teaching you about geometric series. Now, a geometric series is to a geometric sequence just as an arithmetic series is to an arithmetic sequence. A geometric sequence could be something along the lines of 1, 4, 16, 64, ... where we're multiplying by the same thing each time. Each time we're multiplying by 4. And so this is a geometric sequence. So a geometric series would be something along the lines of 1 plus 4 plus 16 plus 64. Just adding up the geometric sequence. Okay, so now let's look at the general idea of a geometric series. So let's say we've got this sum, which is equal to a, because our first term is a, and then we've got a common ratio, so the next term is ar, plus ar squared, plus ... up to ar to the n minus 2 plus ar to the n minus 1. And that there is a geometric series, a general form of a geometric series. But what we really want, we want an easy formula for s. So what I'm going to do is I'm going to multiply everything by r. Because this is all about multiplication, we unfortunately can't do that trick of just switching it round. Things don't add up nicely. So the trick here is actually to shift everything using a multiplication. So I'm going to do SR, multiplying everything by r, is going to give me AR plus AR squared plus AR cubed plus ... plus AR to the n minus 1 plus AR to the n. Because every term, here I've got r to the 0, so I multiply that by r and I get r to the 1. Here's r to the 1, so I get r squared, and so on and so forth. Every term has got its multiplied by r. But what is really nice now is that every term matches up with a term in the existing sequence, in the original series, but offset by 1. So we can just go all the way along, matching them up like this. So this is the key thing. If I subtract them, I'm going to end up with, because we want to get rid of most of these terms, S minus SR is equal to, well, it's going to be A, and then the blue cancels, the red cancels, the green cancels, all the way along, and we're just left with AR to the n, but remember we were subtracting, so it's minus AR to the n. And now, this is really easy, we're pretty much done. We're just going to do some factorising. We get S lots of 1 minus R is equal to A lots of 1 minus R to the n. And so S is equal to A lots of 1 minus R to the n all over 1 minus R. And there we go. This here is our general formula for a geometric series. If you want to find the nth term of a geometric series, it is A times by 1 minus R to the n over 1 minus R. Okay, so now let's use that for a couple of questions. Calculate this following geometric series. So we know here we have our formula. Our series is going to be equal to A lots of 1 minus R to the n all over 1 minus R. And we know that A is equal to 125. And we know that R is going to be equal to 100 over 125, which is in this case going to be 4/5. So we can just plug those in. S is equal to 125 multiplied by 1 minus 4/5 to the power of n all over 1 minus 4/5. Which is quite nice, except we don't know our n. So we're going to have to use our previous formula. Un is equal to AR to the n minus 1 to work out what our final term is, what part of the sequence that is. So we'll plug that in, we'll go Un is equal to, A is still 125, and R is still 4/5. But we know that UN, of course, is 32.768. And then we're just going to divide. So we get 4/5 to the power of n minus 1 is going to be equal to 0.262144. And now at this point, you can work out n potentially by trial and improvement or by using logarithms. So let's go down the log route. We know that we take the log base 4/5 of both sides. Or you could take any log of both sides and then divide, simplifying that way, but I'm going to take log base 4/5. And that gives us n minus 1 is equal to log base 4/5 of this, which is going to be 6. And therefore n is equal to 7. And now we can just plug that into the rest of our calculations. We have S is equal to 125 lots of 1 minus 4/5 to the power of n, but we know that n is now 7, all over 1 minus 4/5, which is going to simplify to 625 lots of 1 minus 4/5 to the power of 7, and we can calculate that. And we get an answer of 493.928. And there we go. That there is our answer to the sum of this geometric series. That's all the terms added up. Of course, given this case, it turns out there are only 7 terms. You could have actually just done that by hand and just added up the 7 terms, but hey. Okay, geometric series has first term 1 and a common ratio of 0.6. Find the minimum terms needed for the series to exceed 2. Again, this is another one that can actually be just done by hand. You can try it out and just go, well, the first term is 1, the next term is 0.6, and then keep going until you get above 2, until you've added them up to get above 2. But let's go through the algebraic method. So we want that a lots of 1 minus r to the n over 1 minus r to be bigger than 2. We want to know when that is going to exceed 2. Okay, so now we're going to put in our a and r, which actually we've been given. So it's going to be 1 lot of 1 minus r to the n all over 1 minus, except of course r is 0.6, let's put that in. 1 minus 0.6 needs to be bigger than 2. Quick simplification, that gives us 1 minus 0.6 to the n over 0.4 needs to be bigger than 2. Multiply by 0.4, we get 1 minus 0.6 to the n needs to be bigger than 0.8, which means 1 needs to be bigger than 0.8 plus 0.6 to the n, which means 0.2 needs to be bigger than 0.6 to the power of n. Now, at this point, I'm going to take natural log of both sides, and that's for a good reason. I could take log base 0.6, but doing that will actually obscure a key part about the inequality. So I'm just going to take the natural log of both sides. Now we can simplify that using our log laws. The natural log of 0.2 is bigger than n lots of the natural log of 0.6. And then I need to divide by the 0.6. And now at this point, what I've written down is wrong. But why? Well, and actually the reason why it's wrong is that this here is a negative value. And when I divide by a negative, I have to switch the inequality around. So in fact, that's our inequality now, because the natural log of 0.6, because 0.6 is less than 1, is negative. And so we've got to be careful in those regards. And then we just need to plug that into a calculator and work it out, and we get that n is has to be bigger than 3.15066, which means n must be 4. The first time that it goes larger than 2 is at n equals 4. Okay. Thank you very much for watching, and I'll see you in the next video.